Okay, the following video will introduce us to proving that two triangles are congruent using the congruence postulates. Okay, in proving that two triangles are congruent, we need to analyze the given. Okay, for example, here, AD, segment AD and segment BC bisect each other at M. Now, we need to do the markings that are implied by the given. Okay, so they bisect each other. That implies that this has the same length as this one because they are bisected at that point there. And also, these two should be the same measure as that. Okay. Now, if we want to use any of the postulates, SSS, SAS, or ASA, we need to find out what should be the third corresponding parts to be congruent in this problem. Okay, we know that AM corresponds to MD and BM corresponds to MC, and they're already congruent. So we already have two pairs of corresponding sides congruent. And we are fortunate to have another pair of congruent sides, which is also given. Okay, so this one here is congruent to this one here. Now, I have the recipe now of two congruent triangles. I have three pairs of corresponding sides that are congruent. Okay, so my analysis there is complete. So I can now begin to write the formal proof, okay? For the first statement, okay, this will be your statement and this will be your reason, okay? Number one, you always have to start with the given. AD and BC bisect each other, okay, at point M. That is given. Okay, number one, there is given. And then also, segment AB is congruent to segment CD. That's also given. I may not write this one here, AB and congruent to CD. I may write it later, but since I've already done that, I just have it there. The next step here is I will have to find out the implication of these two segments bisecting each other. I have shown it here, which means that the measure of segment AM, which is AM, is equal to the measure of segment MD, which is MD. Also, I have here BM equals MC. These are real numbers measured. The length of AM is equal to MD. The length BM is equal to MC. All because of the reason there will be definition of bisect. Okay, we bisected. They bisected each other. Okay, now, if you will notice, this is already one corresponding sides congruent, and this is another pair of congruent sides, and this another pair of congruent sides. In other words, I already have all the corresponding sides congruent. Now, I can now say that the triangle I'm proving, triangle AMB is congruent to triangle DMC. Here, my reason here is what? SSS postulate. Okay, postulate. Let's take a look at this number 2 here. I could have had a while ago AM congruent to MD. And then BM is congruent to MC. And the reason is definition of bisect. Here, these are in terms of segments. Here, these are in terms of, what's this? Real numbers, okay? So, um, if I have to have congruence, we speak of congruence, I should have transformed this into congruence, okay? So, I could have inserted, let's say I will have 2A here. I could have inserted this. And then, my reason for that will be what? Definition of congruent segments. Okay, when you rewrite congruence to this real number form or real number form to congruence form, that's the same reason, definition of congruent segments. Now I have already this side also here and then the sides here, okay? But I don't really need to require to do that. For as long as you have had this already, you can go immediately to number 3. You can now say that triangle AMB, that correspondence, is congruent to triangle DMC. Yan. That's SSS postulate. Okay? Now, let's take a look at number 2. They are almost the same. AD and BC, segment AD and segment BC bisect each other at M. The same given. However, we are not given this. We don't know what these are here. Okay, so if we make the markings that we are implied by the given, what can we have here only? That they bisect each other, so this is congruent to this, and this one is congruent to that. Here we cannot use SSS anymore because I cannot show that AB is congruent to CD. That's actually what we are trying to prove now. So we have a choice. Can we establish ASA? Can we establish SAS? Okay, if we try to reason out with ASA, we do not know the relation this one and this one. No, we don't know the relation. We also don't know the relation of C and D. What we know here is that S and S, S and S. So we know that we already have two corresponding sides congruent. The only thing that we have to show is this. Do we have the included angles congruent? Now, let's see here. From this diagram, let's say this one is angle A and this one is angle B. And angle A and angle B are vertical. And what do we know about vertical angles? They are congruent. So we can actually show that this angle is congruent to that, and we will reason by SAS. Okay, so let's have the first statement. The given is what? AD and BC bisect each other at M. So that one is given. Now, I can say that angle A and angle B are vertical angles. Okay? The reason here will be what? Definition of vertical angles. Now, what do we know of vertical angles? Very popular theorem. The vertical angle theorem is that angle A is, no, small a, is congruent to angle B. This will be VAT. Vertical angles are congruent. That's the vertical angle theorem. So now, uh, we have that angle A and angle B. I should have had first the implication of number 1. Okay? But since I've already had this, I'll just write number 4 as implication of number 1. Okay? I can now say that since AD and BC bisect each other, I can say that AM is equal to MD, and also BM is equal to MC. The same reasoning above, we have definition of bisect. Okay? And then I can have this one here, or I can now say that I have this angle, I have these two sides, including which are including this angle. Then I can now say that what? The correspondence triangle AMB is congruent to triangle DMC by what? SAS. Number 4. Number 5. SA, this is number 3. SAS postulate. Okay? And take a note here that if two triangles are already congruent, what can we conclude? The corresponding angles are congruent, the corresponding sides are congruent. So I can now conclude that side AB here corresponds here to DC or CD. They must be congruent by number 6. Remember this, instead of saying definition of congruent triangles, we say what? Corresponding parts of congruent triangles are congruent. So that's the abbreviation, CPCTC. Corresponding parts of congruent triangles are congruent. There you go. We were able to demonstrate two examples using SSS and SAS postulate. What did we actually do? First things first, you have to look at the given and try to mark it in the figure. Okay, and then you want to prove that two triangles are congruent. So I can say here, exclamation point, I want these two triangles to be congruent. Okay, so, and we have the proof. In this other problem, we want to show that segment AB is congruent to segment CD. That's an offshoot of you arriving at triangle 1 congruent to triangle 2. So if you have these kinds of problems, you need to show first that there will be two congruent triangles. Okay, and then if you want to prove that AB, segment AB is congruent to CD, now you have this as an exclamation point, okay? Which means that's the one you want to arrive at. This segment is congruent to that. Here is the triangles. That's why I had the exclamation point inside those two triangles. Okay, so there you go. Um, let's have other exercises in your class.